everyone, I hope everyone's doing okay. I'm very sorry I haven't been posting a lot of videos, so I highly apologize for that. So, to make it up today, I'm going to do chemistry, and we're going to do the fourth chapter, thermodynamics. So, what is thermodynamics? What does thermodynamics actually mean? So, the subject of thermodynamics deals basically with the interactions of one body with another in terms of quantities of heat and work. Next, in this thermodynamics, there's something called a system. Okay, there are two things which involves the system. See, this system is defined as the macroscopic part of the universe, which is at the moment still getting investigated. I mean, it's still investigating because they are not fully explained what is there in system. Okay, but for now it is the macroscopic part of the universe. That is one part of the universe. But what's the second part of that very universe? That very thing is called the surroundings. The surroundings are rest of the universes the rest of the universe outside the systems. The surroundings are the rest of the universe outside the system. So, what makes the universe? A surrounding and a system. These both basically makes the universe. Surrounding plus system gives you universe. Now, next is the boundary. Boundary technically means bounds. Like there's a wall in between and it's keeping them separate. So the actual or the imaginary surface in this case separates the system from the surroundings. So the surroundings and the system are separated by a huge wall, and that wall is called the boundary. So this system contains three types. It is an open system, a closed system, and isolated system. The open system can exchange matter as well as energy with the surroundings. Closed system can exchange energy but not matter with the surroundings. As for isolated energy, cannot exchange both matter as well as energy with the surroundings. So open system means matter and energy it exchanges with the surroundings. For the closed, only energy but no matter. Isolated, no matter and no energy. Okay, it's not exchanging both of them. Now we have learned the three types of the system. Now next is thermodynamic properties. What are the properties of the thermodynamics? So there are two types of properties, intensive and extensive properties. So the intensive properties are the properties that do not depend on the amount of matter present in the system. As for extensive properties, they depend on the matter present in the systems. So the intensive means they do not depend on others, they know how to handle themselves. As for the extensive, they depend on that very amount of matter in the system. Now, the examples of intensive properties are pressure, temperature, density, melting point, and boiling point, or etc. As for extensive, mass, volume, heat, capacity, enthalpy, entropy, etc. We'll get to that later. Next is the thermodynamic process. So what is this thermodynamic process? The change of a system from one state to another state is known as the thermodynamic process. So what are the types of thermodynamic processes? Here, first one, isothermal. The name itself gives the explanation. Thermal. Thermal means temperature. So here, the temperature remains constant throughout the process. That is, dt, capital T, is equal to 0. So thermal means the temperature, while iso means it's constant or equal to 0. Next is isobar. That's the second one. That is, pressure remains constant throughout this process. Pressure's unit is bar, right? So isobaric. atmospheric. So that is dP is equal to O. P represents pressure. Next is isochoric. Isochoric is the volume that remains constant throughout the process, is known as isochoric. So here choric means volume, while iso means, as usual, 0 or constant. So here D capital V is equal to 0. Next is adiabatic process. So here the system does not exchange with the heat with the surrounding. So here the system and the surrounding is there, but they do not exchange heat. Okay, system does not exchange heat with the surrounding. So here dq is equal to 0. And last is polytropic, that is pvn is equal to constant. So P represents pressure and V represents the volume, but this PV raised to n is equal to constant. Thank you for watching this video. This is the end of part 1. And before leaving this video, please subscribe, share, like and comment, of course. This is Aditya Krishna Raj signing out.